Hello everyone. In this example, I'm gonna demonstrate how to use the voltage and current division to get any unknown values. Now he's asking for find V1. V1 is this voltage and I2 is this current. Alright, now let's think of our circuit. Usually when you have any circuit, you have to first name all nodes. So if I go and name this node, this is node A, and then this is node B, and this one is node C. Now if we look at those combinations, I would notice that those two resistors, they have the same node color code, right? That means they are in parallel. How about this one? This one has a different node, so it's impossible for this one to be in parallel with those. So if you wanna do a voltage or current division, first of all, you can't do it with so many resistors in the circuit. You have to have only two resistors on. So if I'm looking here, I have to simplify this circuit. So I would start with the parallel combination. But remember one thing, when we do a parallel combination, it means that the nodes, right, would stay, the voltage would stay the same because you're adding two parallel combination, but the current would disappear, because we said earlier, if you have a two parallel combination, they share the same node, the same voltage, but they don't share the same current. That means this current here and this current here are different. That means if I combine those two, it's like you combine this current with this current, so you will get a new current. So you can't name the current in the new combination I2. Alright, so let's pay attention to this point because it's really important. Now let's redraw the circuit. 24 volts, and then we have 6 ohms, and for here I'm gonna have a new resistor which is 3 parallel with 6 should equal 1 over 3 plus 1 over 6, right? This is the parallel combination rule. So when I do this in the calculator, or you can do it manually, you will get 2 ohms. Okay, so here I'm gonna draw 2 ohms. Now if we look at this circuit now is having a voltage here which is V1, and this current disappeared, I2. So I will be able to use, since I'm having here a voltage source, to use a voltage division between those two series combination. Now if we look at this circuit, it's a single loop. That means the current here is the same here and the same in the 2 ohm. That means they are in series. We said the condition for any combination to be in series, they must have the same current. The current cannot be splitting, right? So now we can say V1 should equal the voltage source, which is the voltage that acting on both resistors, 24 volts, times, now which resistor I want to find the voltage in? The 6 ohm, and we always multiply by the same resistor, so it's by 6 over 2 plus 6, and this should equal, if we calculate it, should equal 24 over 8 is 3 times 6, which is 18 volt. Okay, this is V1. Alright, now to find I2 using current division, right, because he asked for using voltage and current division to find V1 and I2, I should find the current that is flowing here, that is entering this node. Since I'm having the voltage V1 and I have the 6 ohm, so wouldn't it be possible to find the current I1 which flows through the 6 ohm? Yes, it is possible. So I'm gonna say now, if I call this one, I'm gonna call it I1. I1, look at the pathing of I1. I1 would flow through that source, continue through the resistor, and reach this node, and then it would split into the 3 ohm and the 6 ohm, but it does not have to split in half. It only splits in half if those two resistors have the same exact value. But now the I1, when it entered here, it has to go in a ratio depending on the values of those resistors, and here where we use the current division law. So let's use the current division. Let's first calculate for I1 and then use the current division law to calculate I2. Alright, so I'm gonna do now Ohm's law. Ohm's law would tell me that you should divide the voltage that you have V1 over, right, the resistor, which is 6 ohm. So I1 should equal V1 over the 6 ohm. That means V1 is 18 over 6, which is 3 ampere. Okay. Now I just want you also to remember, always check if your voltage or current is positive or negative. Now this voltage is supplying voltage. That means it would push the current from the negative to the positive polarity, right? Because it's gaining it's gaining potential power. So this is going, the current going here and then going here. The current must enter the positive polarity of the resistor. That means this voltage has the correct sign, it's positive. Now, since we found I1, which is 3 ohm, when it enters this node, it would split, but not in half, it would split according to the current division law. Now, if I want to find the current in the 6 ohm, let's first examine the direction of this current. Now, I1 would enter this node, it would go down and then go to the right and also down. So this current has the opposite direction. That means I2 must be a negative. And then the current that entered the node equal I1. So the current that I'm going to use here is I1 multiplied by. We said for the current division we have to multiply by the other resistor, not the same resistor. So I'm going to multiply by the 3 ohm over 3 plus 6. That means I1 is 3 ampere times 3 over 9, which would equal negative 1 ampere. And here we go. This is a demonstration of how to use voltage and current division. In next, stay with us for next video. There is more coming. So I hope you got the entire subject of current and voltage division. I will see you next time. Bye.